Okay, then I think we should just start here. We are a couple of minutes late already, and I guess those who haven't arrived just yet, they will be arriving shortly. So first of all, welcome all to this webinar, which we are sharing with you today. It's about the PAT and Principles 2 in process industries, as you all seen in the invitation. In the meeting today, it will be myself, Geir Rune Flåten, who's going to be talking to you. So I'm going then to present you both a little bit about PAT, and I'm also going to talk a little bit about the new software which we are proud of here in Camo, the Process Pulse 2. And as you see on my screen now, we have my email address there. So if you have any questions, for later, please feel free to contact me. If you have any other questions, things like availability and so forth, you can contact Jostein Hareide, and you can then send just an email to sales@camo.com. And today, as I said, I'm going to talk about a little bit about Process Pulse and PAT, but you should be aware that during the autumn now, we will have a couple of other events which some of you might be interested in. We will have several training events. We will have some training in PAT, some training in DOE, and also, of course, our standard MVA offerings, which is more or less all the time. In addition to this webinar, we are also planning to show you webinars on the new batch method or the new batch module, which we are putting out now in September. And also we have a couple of webinars which is more generic webinars on MVA, which is more the standard methods which we are working on in Camo. Also, if you want information about this, just go to the web page, and there you should find everything you should be needing. Okay, as I said, today we are going to talk about Process Pulse and PAT. Let me just change the like so. I'm going to talk first a little bit about PAT and sort of what we're thinking in the process industries, how PAT can be used. But this is just going to be like a brief introduction. And the main part of my time today, I'm going to use to talk about Process Pulse 2, and also then give you a live demonstration of how we see this being used in connection with PAT and processing industries. Going to talk about functionality, of course, and also have a little bit of a case study for you. And towards the end, we will have a Q&A session where I will open up for you to ask questions. And of course, if you have any questions during the presentation, please feel free to just send a message to this into the system. And then towards the end, I will go through them all. Because of the number of participants here today, I won't stop for questions during the presentation, because that can be a little bit messy, should we call it that. But as I said, feel free to put in the question as you get them or as they develop, and then we take them towards the end. Okay, PAT first. I guess a lot of you guys who are on the line or who are listening in, you know what PAT is. But let's just start with one of these definitions. There are several definitions around, but one which is pretty good, I think, is this one which FDA came with in 2004 in connection with their white paper on PAT. And they call PAT a system for designing, analyzing, and controlling manufacturing through timely measurements. And the focus then should be on the critical quality and performance attributes of the raw and in-process materials and processes, with the goal of ensuring final product quality. And if we start to look on that definition, it is actually quite wide, because it's saying that we are going to control both the process and our input materials and have a look at them as we are doing our processing. So if we try to sort of make a picture out of this is how it can look like. We have our process, which could be anything really. It depends on your industry, on your context. And into that process, we have one or more input variables, which is going in, raw materials. And the process is happening, and it could be like heating, mixing, whatever it is. And that is, of course, influenced then by your process parameters, in addition to any environmental factors. And as the process then is progressing, we will get an output result or a product, and that product is really what we are interested in, because that is what we can sell on or pass on to our customers. And of course, then it's key that that output product or that product has the right quality. And right quality, it could be anything. It could be purity, it could be something about consistency, it could be surface properties. It really depends on what you're making here. But during this processing here, we obviously want to measure. We want to have some sort of data which is telling us about what's going on. And those measurements, they could be on the raw materials themselves, or it can be on the processing vessel. And using those measurements, we then want to have a handle on the quality, which means that we want to control the process and also to some extent have awareness of what is the quality of our raw materials, so we can actually adjust the process to ensure that the output quality is right. And this is equally generic as the definition, I think, but it's sort of the challenge we're looking at. And if it's a batch process, if it's a continuous process, whatever, it's actually the same picture we're needing to understand or needing to address. And of course, this PAT, it's nothing new in its own right. This process analytical technology, it's been around for quite some years, and depending on industry, it's been more or less widespread. But this means that there is a number of different successful examples of PAT implementation. And on this picture here, or in this slide, we just have a couple of them listed. You could think about moisture control. A lot of industrial processes, they are relating to drying and sort of getting the right moisture of the materials. We could think about things like blending uniformity. That is very important because, of course, if we are thinking, for example, pharmaceutical industry, and we are making tablets, say, we need to ensure that the active component in each tablet is the same, so that the patient is getting the right dosage from each dosage form. Another example from the pharmaceutical industries, it's about the quality of the tablet, call it tablet hardness. And of course, that's important because it has something to do with how durable our tablet will be. We could also think about, depending on what we're making, it could be crystallization processes, which we might need to control because of the quality requirement. And it could be standard chemical reactions, which we just want to monitor to ensure either that our yield is where it needs to be, or that the purity of our components are right. And of course, another sort of PAT application is this raw material identification. And identification in this context is not only about seeing what material we're having, because obviously that should be more or less known to us, but it's also about the quality of the raw material we're looking at. What type of quality are we working on? And in some industries, like agricultural, it might be some seasonal changes to our raw material, and that means that we need to run our processes according to those changes in the raw material. And in order then to do these different examples or to solve these problems, obviously we need to have a lot of capabilities present. We need to know something about manufacturing. We need to know something about chemometrics, which is in our context data analysis. We need to know something about the chemistry which is going on in our product, and also a little bit about how can we actually measure our product. Experimental designs, that's an advantage because that can help us to develop experiments which are the right experiments to get the information we need. And of course, when we are doing our measurements and when we're doing our experiments, we need to have some control on the information coming out of these applications or these systems. And that relates then to the information management. And of course, if we are doing measurements using advanced sensors like spectroscopy sensors, near infrared or something like that, we need to know a little bit about the measurement methods themselves. And also, in order to take advantage of all of this information we're gathering, we need to know something about the process control system. because maybe we want to say that for moisture, for example, we want to dry until the drying is completed. And that means then that when we reach that completion or that moisture level in our product, then we need to stop the processing, stop the drying. And that's of course happening through the control system. Okay, so if we then move on to an example, it's a petrochemical example, but it illustrates the sort of opportunity we have with PAT very well. Because what you see here is that we have a couple of variables, which is reflected in the scores here. And we see that the scores, okay, they are high, but they're still inside the limits. This is now the upper left plot. And it's moving along the upper limit, and then it starts to cross the upper limit and moves out of the upper limit. And we get a peak towards the end of the plot or towards the end of the time series. And this is then, when that peak is happening, that is when we are really seeing it in our manufacturing operation, that this is something going wrong here. And also, if you're looking on the score plot upper right, you see that that's where we're really moving away from our ellipse. And that ellipse is, of course, describing the normal operating region. So at that stage, it's easy to see that something went wrong. But if we, in hindsight, analyze our data, we see that if we had reacted when our scores value were high and starting to approach the upper limit, then maybe we could be in a different situation, and maybe we would be able to save this batch or save this run, rather than having a situation where everything is moving out and we're getting a big problem. And of course, the idea then is that if we had a PAT system which was measuring as we were processing, and we were able to take advantage of the measurements coming from that system and feed this information to the control system already at this stage when we're crossing the limits for the first time, then we would probably be able to do something. At least we should be able to stop the reaction or stop the production to avoid that things are developing maybe into clogging or something dramatic, which takes a lot of effort to fix. So if we think about PAT then, it's sort of easy conceptually because I showed you the plot initially about input, the processing and output. But when we start to look at this and when we try to actually do it, there are some challenges popping up. And those challenges, they're actually spanning the whole range of skill sets which we said was required for this PAT method, because you can think about the PAT measurement system. And the first question then, of course, is to have some understanding about what measurement system should we actually be using, because we need to know something about how we can measure these properties of interest. We need to know something about what will be feasible measurements for our context. And of course, we need to think about how we should handle the data coming out of the measurement system. When we have the data, we need to think a little bit about how are we going to use the data. What models are we going to use? How often are we going to maintain those models? And how reliable are those models actually? Because a lot of models, they might be just qualitative in the sense that they are giving us an indication, while other models, they can be very quantitative. So they might give us the precise yield or the precise moisture in our process or in our context. When we have both the measurement system and the models in place, then we need to think about the PAT method and start to think about how can we actually validate this method. How can we justify that the method we are going to run in our process is right and it is feasible for what we are going to use it for. And that is, of course, some challenges there, because the context of a process is online, and maybe you have a big or large vessel which you want to run your reaction in. And that means then that it's not straightforward to just do repeated runs to get your method validated. You need to think carefully about how you can validate the method without actually throwing away a lot of material or having a lot of trial runs. And of course, there is also this question about, if I have validated my method successfully, how do I maintain that validation in case of changes of personnel, changes of hardware, or maybe even updates of the model or maintenance operation of the model. The last point on this slide is about operation of the method, because one thing is to develop a PAT method in a small scale facility or in a laboratory, because then we have a system which is controlled and it's very easy to have an overview of that system. But when we are putting it out in the process itself, what we are expecting then, or what we are needing, is operators who might not be PAT specialists, but just people who know how to run the process, and they need to be trained and they need to be capable of running these methods, these PAT methods. And then the question is, how can we actually do that, and how should we then ensure that the observations they are making in the plots, for example, like we showed on the last page, is actually going to be used in a beneficial manner, and ensuring then that the right information is coming to the decision maker who can do something about the process before things are getting out of control or getting to the stage where you are actually losing your batch. Okay, that was what I was going to say about PAT. As I said, I was going to be brief, and I think I was. And if you need to know more about PAT, if you are sort of new to this, please feel free to get in touch. And also, as I said, we are going to run a PAT course later in the year, which will be taking up more of the details. And we will go into those challenges and look on how they can be resolved in what we think is a reasonable manner. What I'm going to talk about now is something I call Camo products. Not going to be long here either, but it's just to give you a context of this Process Pulse 2, which I'm going to focus most of my presentation on. Because in Camo, we have one, should we call it heritage product, which is the Unscrambler, and that is pretty much where Camo started from. This is a data analytical tool, a multivariate data analysis tool, which has been around for about 30 years. And what you can do in that tool is that you can analyze your data. Typically then you have your data in some sort of historian or in spreadsheets or somewhere, and then you can import them into Unscrambler, and you can run different analysis on those data. You can create explorative PCA models, you can create calibration models, do predictions with new data if you have that, and so forth. It's pretty much a data analytical tool. And also in that data analytical tool, we do have experimental design set up. So that means that in addition to do analysis on existing data, you can also plan new experiments to ensure that you can do as few experiments as possible and get as much information as possible out from your lab or from your process itself. And about that DOE, it's quite exciting now, because in just a couple of weeks we will release a combined product from with Unscrambler and also with the design expert from Statis. And that means that you will get all of the functionality which design expert has, and you will be able to combine that power with multivariate data analysis power in Unscrambler. That is for historical data analysis and planning of experiments, as I said. The other one here is the Process Pulse. And in short, that is for predicting data or running models as we are getting new data. And this is then, you could call it an online opportunity for running models. And that means that if you create a model in your Unscrambler, you can use it with Process Pulse in your environment, be it a lab, be it a pilot plant, be it a processing plant itself. And the two items on the bottom here, the customized process solutions and training and consultancy, not going to talk much about that, just let you know that yes, we are doing that. If you have some special challenges in your process on heritage systems or something like that, yes, we can help you to sort that out and get the data into Process Pulse. And also, if you think that the first step for your organization is to get some more training and maybe do a bit of consultancy pre-projecting of your project before doing the implementation of PAT itself, then you should talk to us. The vision we have then is that all of these products, or both of them, shall we say, they are working together to enable us to close this circle of, we call it the circle of continuous improvement. You will recognize it maybe as quality by design. and also it's fitting other data-driven methodologies such as Six Sigma or lean manufacturing and so forth. The starting point then is that you have some data in a historian, in a spreadsheet somewhere. You take those data into Unscrambler, and then you can build models. And if you get some models which are of interest, then you can use these models. You can either use the models directly in your instrument. So as you are doing a new measurement, for example, you are getting up a prediction value instead of the spectral data. Or you can take it back into the process and you can run the process pulse, or you can run the model in process pulse, and thereby ensure that you are getting, again, prediction results as you are running the process itself. And that is then put on the plant floor, and that's generating more data. And you can start to think about updating your models if they need to be updated. Or maybe as you are generating new data, you find new relations between your process parameters and the quality of the product, which means that you can create new models and you can start to iterate towards a much better process. You can increase the process capability in your processes and so forth. And if you put the Six Sigma or the MAIAC on here, you see that it's the cycle of measuring, analyzing, improving, and controlling. So it's, as I said, what our vision is to provide you tools which help you to do data-driven manufacturing in short. And as I said, it has different labels, but it's the same thing, which is the ambition here. Okay, that was sort of the Camo vision. And the next one here is Process Pulse itself. And in order to say something about Process Pulse, I think we need to give you a little bit more background on the idea of the product. And as I said, in short, it's all about running models in real time or in the environment where your action is happening. You can apply any models you will be able to develop in Unscrambler, such as regression, classification, projection, hierarchical models, and more. And that gives you the opportunity then to assess the state of your process. And in some industries like pharmaceuticals, they have this expression which they call the science space. And the science space is basically where you want to be. It's a description of how the process should behave if it's running as it should. And in that situation, we can assess the data which is coming in from our process, and we can compare it to the design space, which we know is the good situation. And if we are seeing any issues, like I showed you in the earlier plot, we can identify those, of course, and then we can report it, or we can take action and ensure that those issues are not allowed to develop in any way. And of course, this is fitting straight into different continuous improvement programs and CAPA programs, so it's no conflict there at all. If you're thinking about where this process fitting in, it is really meant to be scalable from the one sensor in the laboratory maybe, all the way up to multiple sensors, multiple process lines, multiple sites even. And that means that we will be able to use it in a pilot scale manufacturing. If we are thinking about developing new products, maybe on a pilot, the Process Pulse gives it the opportunity to quickly collect data from a number of sensors, and then also to present those data as we are generating the data. And after just a few runs, we can start to think about modeling those data and test out models already early in that development cycle. So we don't have the situation where we need to run the process for a long time before we have data which we can start working on. Obviously, the more data we have, the better description of our process we have, so it's easier to make better models, but we can at least start it early. You can also think about using Process Pulse in a laboratory setting, and maybe then in a quality laboratory. And the opportunity there is that the different sensors or the different instruments, they can be connected to Process Pulse. And as you are doing the measurements, you are storing the data in the Process Pulse database, and you're also getting the prediction presented on the screen, and maybe even put out in a report. And that gives you another opportunity there is, of course, that if you link the activity in the lab with the activity in the pilot scale, then you can quickly feed the information back and forth between the two. And of course, you can do the same thing with the process itself as well. When you get into the processing floor or manufacturing floor, where you are running your, should we call it, the real processes, making product for you, that's where it's critical, I would say, that you have a look on what's going on and also understand if things are about to take a turn for the worse. Of course, to use the process pearls in the processing situation or in the manufacturing situation, it needs to be, should we call it, validated? It needs to be trustworthy. So we have ensured then that all of these developments, they are in line with the requirements for uh, regulated industries. So that shouldn't be a problem. But of course, if you have a special interest there, you should come talk to us. Contact me first, and I'll put you in touch with the guys who are in control of that. Okay, so I said then that process pearls, we can run models and we can get a real-time look on what's going on in our process. And here we have represented that with the traffic light system. So the process can be green, everything is okay. It can be amber, something is suspicious, or it can be red, which tells us that this is an alarm situation, do something quickly. But what I haven't focused on just yet is that the process pearls, you can also connect to a number of different sensors. And here you see a example setup where we have a number of advanced sensors from well-known vendors. And also we have some examples of databases, OPC, OCSoft databases, and also we have a ThermoLIMS database at the end here. And the idea then is that process pearls is able to connect to these different data sources, pull data or receive data, and then create or run those models and create results for you, which can be presented on a screen or which can be stored in the database itself. And that means then that in many ways you can regard process pearls as a data collection system as well as a model execution system. And that gives us a sort of stepping stone into this PAT system world. And this means also that I talked about the pilot scale situation for process pearls. If you think about actually documenting your pilot scale, your product development, all of the data will be contained in the process pearl system, and you can then create reports and development plans and everything from those data. And of course, this database is also possible to use in the enterprise system, which means then that you can, again, have this database as a primary data source for PAT data, for example. You can collect all of those data in that database, and that's where you have them. That's where you can access them. And I will show this later, of course. We also put in Unscrambler here because this is relating back to the circle I talked about just a little bit earlier. Because in Unscrambler, we are accessing the data and we are creating models. And these models, those are the models we are running in process pearls. And that means that the link now between process pearls and Unscrambler is key. That is the most important thing about process pearls, is that it links very well with Unscrambler. And that means that all of the benefits you have from the easy-to-use model development in Unscrambler can be utilized directly in process pearls because you just upload the models or take it into process pearls, and then you can use them. And it is really straightforward if you are familiar with Unscrambler. And also, of course, we like to think that Unscrambler it has a low threshold for use, which means that even if you don't know Unscrambler from earlier, it should be easy for you to start using it and get the models you require. Okay, so if you think then a little bit more about process pearls and what it's doing, okay, it's the same circle which you saw before, just in a different representation. But I have some data available, either from my data historian or from the process pearls historian itself. That data is giving me the opportunity to develop a model which is describing my data. This model can be transferred into the process pulse system, or for that sake, between process pulse systems at different sites. Then I connect to my data source, and when I connect it to my data source, I'm getting the data into the system. And these data, they are collected as process data. I can execute my model. I present the results either to the end user via a visual display, or I present it maybe external to a third-party system, like a control system. I can send out the data. And either way, I will save my data and save my results. And that means then that either straight away or next week, I can generate reports telling me how my process was running now. And also these reports, they can be somewhat tailored, so you can create your own reports. But the reports, they will just then be feeding into some storage somewhere. You get more data, and of course you continue this cycle of continuous improvement, or quality by design, or Six Sigma, or lean manufacturing, or whatever you want to call it. And if we look a little bit closer then on how this is working out in production itself, well, I have here on the left-hand side the raw material going through a process to an end product with the right quality. And what we're really doing with the unscrambler process pulse is that we are monitoring data coming from the process. We are collecting those. We are executing the models which are required for those data, and generating some output. And of course, when we have that output, there are two main outcomes, because we can have a situation where the result, the output is okay, and that means that we have a green light for our process. Everything is on track. It is as it should be. We are within the design space, normal operating region. Or we can have a situation where the result is starting to deviate. Well, either starting to deviate, or is deviating. And in that case, of course, we need to think about what we should be doing. We need to take some action. That action can be done by an operator if they are trained and told what to do, or it can be an action which is taken by a control system if you have connected process pulse to the control system you have in your on your manufacturing floor. Either way, as I said, the results and the data is going to the data historian. And that's where it's stored safely until you want to use the data again. And these data, well, you can, it's not shown in this figure, but you can have a review of the data in process pulse itself, and I will show you that. Or you can take the data into a scrambler where you analyze them, and maybe you either maintain, modify a model, or you build a new model. And anyway, any models you are building in a scrambler, you can take back to the process pulse system where it's again executed, and you can continue this loop, and you have this continuous improvement cycle going. You also have the opportunity, of course, to run several models on your data. So if you want to test out a new model, you don't really have to replace that old model which you are still running. You can have the two models running at the same time on the same data to just give you a comparison. But this is all down to what you want to do. Okay, so now we're getting to the demo part itself. And as I said, as I started, I'm not going to open up for questions during the presentation here, because I think that because of the numbers, as I said, it will just be very very difficult. But I will move on with the demo and open for questions afterwards. So before actually showing you process pulse, I will tell you a little bit more about the features, going down into detail. Not too detailed, because if you have any specific questions, just come back to me in an email, or contact Jostein in an email. The first thing I want to say something about is this user interface, because we think, and obviously you are the judges of that, but we think we have created a user interface which is both intuitive and easy to use. And that is key, of course, because the tool here, process pulse, it shouldn't be hard for you guys to use that tool, because it should simplify your life, and it should make it easier to use PAT, or to do PAT. We also putting in place a web dashboard here, which means that if you want to have a web dashboard which you are sharing either on your intranet or something like that, it's possible to do that, but that depends on your requirement. In terms of data import, of course, we have folder readouts, which means that if you have data which is placed into a folder by some system, we can read that. We also have, for some analyzers, we have some direct connections, and that is a list of direct connections which we are planning to grow as we are working with more and more analyzer vendors. We also have these standard connections to standard systems, so the OPC for process parameters. OCPI, which is a fairly big player in this process parameter domain. And also we have this database connection, ODBC connection. It is possible to do parallel import from multiple data sources, and you can also do alignment of the multiple data sources in real time. In terms of data visualization, we think that is key, because what we're trying to do here is to, okay, record data and run models, but we're also trying to translate the measurements into something meaningful for you so you can take the right action. And that means that these visualizations, they are the key here. And we have done a lot of work already, but obviously this is an ongoing discussion about what is the best way of presenting the results, the statistics, so that it's actually possible to act on in an intuitive manner. Part of the visualization is interactive plots. You can drill down to troubleshoot. And also you can do this switching between different data sources and different dashboards. So you can actually have a look on several processes at any one time. This is maybe most relevant for maybe a data analyst or an engineer sitting in the office and following 2 or 3 product lines. And then if something is going wrong on one line, you can focus on that and drill down on that line or in that line. The next thing here is about model execution. As I said, you can run all of these models, which is available in Scrambler. The results from the models, they can be visualized in real time. And any deviations which you see, they can also be investigated in real time. One thing which we are again working on extending the list of is this third-party calculation engine, because that means that if you have a preferred data analytical tool which is not Unscrambler, it still might be possible for you to use Process Pulse to actually run your models, because we, as I said, with those vendors which are willing to collaborate with us, we are integrating the calculation engine so you can run those models. And another option, if you have a third-party system you want to work with, is that we can send any results to third-party systems using the standard interfaces like OPC, TCP/IP, ASCII, and so forth. Data storage, we are storing all data, of course, and it's complete and secure and compliant. And this is also used then when we retrieve the data. So you can access the data storage from external, and then you can get data out. Obviously, it's easiest for you to use the Camo tools to access this database, but there's not really a limitation on that because the database is an SQL database. Model storage, we also have the storage of models, because one thing you see when you are working particularly in a team of analysts, you need to keep track of your models. And what we have done is that we are storing the models in connection with the database, and we are able to have revision numbers on the models. So that means that if a colleague of yours is making some changes to the model, those changes will be logged in the audit trail, of course, but also that means that the model will be versioned, and if you then don't approve of the changes, you can go back to the previous version of the model and ensure that you haven't been led too much astray there. Reports, said something about that. That's obviously for getting data into reports which you can share with the management or colleagues. Alarms and warnings, if things are going outside the statistical limits you have specified, then you're getting a flagging of those deviations. We also have a thing here which is we call email warnings, and that means that if you have a nominated responsible person for some of these alarms, you can send emails. So that means that you can take it into a control an alarm controlling system. You also have audit trails. So anything you do in the system is noted, and that means that you can go back and check who's been doing what. And you can create reports on that if you are getting an external audit or internal audit to see what's been happening in your process. You can write out these audit trails, and that should be okay. As I said, this system is scalable, so it's all the way to enterprise solution. And the last point there is about customization, because yes, we are providing a system which is off the shelf, but we also are very keen on providing customization to your system, to your particular data sensors, and to your particular models. So if you have any interest in that, you should again just contact myself, and we can start a discussion on it. Now, the last thing I'm going to show in a slide here before I'm moving into the demo itself is this what we call configuration, because that's basically an analytical method in some terminology. Because when we are making a configuration in process builds, and I will show you that in just a minute, what we are doing then is that we are specifying an input, a data source where the data is coming from. We are specifying a model which is telling you or telling process builds what to do with the data which is coming in, and we are specifying the output where the data is going to be sent, what the results are going to be used for, and so forth. And this thing here, which, as I said, is I call maybe analytical method, is what we call a configuration. So when I'm talking about the configuration later, it's setup of a data source, model, and output specifications. Okay. Then I'm going to try to switch screens. Okay. And I think you should be able to see my screen now. Just put that on top to be sure. Okay, so this is Process Pulse login screen. Now, not much to say here, but you see we have some feeds on the left-hand side, and those feeds, they are not, it's not very meaningful what you see there now. But the idea is that if you want to have a communication to your team, you can put in the feeds here, and then you can update your team. So that's sort of the meaning of it, or the idea behind it. Let's log in. This is now the first screen, or the starting screen of Process Pulse. And what you see here is that, okay, you see in the background that no configuration is selected, which basically means that my system isn't running. Okay, you also see on the top, towards the top there, we have three main areas of buttons. We have the operation buttons, we have the review buttons, and we have the settings buttons. The idea now is that operation is relating to what you do in Process Pulse. Review is relating to what you do after you have been running your process in Process Pulse. And the settings, that's basically setup of the system. And maybe for the settings, we could start to have a look on the user list, because in this system here, I have what we call local user access control. And that means that my process pulse is controlling it. But I could also use what you call Active Directory, which you are familiar with in your companies, because that is the technology you are using when you are using one password to log on to all systems. So this can then be set up as that. Also, you see that I have a couple of, well, more or less dummy users, and they have different privileges. We have privileges for administrator, operator, and developer. Administrator is the one who's sort of controlling everything. An operator is only running different configurations and also able to generate some reports. A developer is the role which is setting up data sources, models, and configurations. and that is sort of the three main data sources. No, the three main user levels. Okay, so the first thing I'm going to do then is that I'm going to go to data source. In that data source, you see that I have a list of different data sources. Okay. In that list, you see that I've given them some names. These names are obviously chosen by myself, so you see the system here is not very meaningful, but you could of course choose whatever names you want. The different types of data sources is relating to what type of data source it is, of course. And in my setup or in my demo here today, I will only use folder readouts. And for those folder readouts, I'm using some different file formats. I'm using ASCII, Opus, you see JCamp, grams, and so forth. And I also have the location of those folder readouts, and you see here that this is different folders at my computer. If it was now a situation that I connected directly to an instrument, or I connected to, say, an OPC data source, then of course the location would relate to that. If we now have a look on one of these data sources, we can, for example, take that JCamp. The first step to do when I'm setting up a data source is to give it a name, and then I select the type of data source. In this instance, it's a JCamp GX. Maybe I can actually set up a new data source so we can actually show you this, because if I call this demo data source, then you see that I have a list now of these different data sources. This is all of the file formats. I have some OPC, PI, TCP/IP, and ODBC. Pre-treatment model, that's something different, and I won't talk about that today. But if anybody of you are interested in more details on the system, we can discuss that. But for now, let's just say we're doing that JCamp DX. And then for all of these folder readouts, I'm told that I need to specify where the data will be coming, and I can do that. I go here to my computer, and I have a folder down here, and configurations, and I do configuration 1, which is a JCamp source. And also I'm told that I need to give a example file for that data source. The idea here is that when I give in my data source example file, I'm also giving dimension of my data. So you see how I take the next, and I'm getting a preview of the data. I will then see if this is the right data, but my system will also know whether this data is compatible with my models when I'm going to choose models later. And that is giving us an opportunity to sort of help you decide. So if I just say finish there, you will see that my demo data source is put on the top here. It's a JCamp GX, and it's this is the link I gave to that data source. So then I've set up my data source, and that's we think easy enough. Next step, or the next thing I need to think about, is about models. And here you see that I have a similar situation which I had before, that I have a listing, and each of these listings, they are models. I'm getting information about when they were uploaded, and you see that I have been preparing myself yesterday and today, uploading all of these models. And you also see that the user who's been doing all of this is myself. GRF is my username on this system. We have something here which is state, which is basically enabled and disabled, because we can have a situation where someone is telling us that this model is not ready for use in production, so we can disable the model. But that's something I won't go into. Here we have what we call a download button, and this is relating to third-party models. If I have some models from a third-party calculation engine provider, then I can download my model. But in my instance, what I have is unscrambler models, all of these. So let us just push this model into unscrambler. And now I'm getting an instance of unscrambler opened. and I'm getting the model sent to Unscrambler. And then I can go in and have a look on this model. I can see what data has been used for this model, the X and the Y data, and so forth. And also, if I wanted to here, I can import some more data maybe, and then I can fix my model. And when I have done that, I can save it. And when it's saved, I can go in here and I can do an upload of model. And then I just browse and find where these models are kept. And again, it's down here in configurations, we find the models. So let's just say this one here. Here we have some models. This is a PLS model. And then I can say open. If there was a situation now that I had several models in my unscrambler file, they will be listed here. So what I need to do is select the model I want to use. And then my model is given a name. I call it demo. I can say something here about what tags I want to use for this model. With this model, this is relating to the model database, and it can be used for searches in my model database later. The number of tags here is dynamic. You can add new tags if you have some specific tags you want to use, and that is then done over in preferences. But in this instance, it's just the two. It's the project name and product. I'm not going to use it much. This side here now, this page, I can actually say something about who should be able to use my model. So let's add these operators, say that both of those operators, that is the wrong one, both of these operators should be able to use my model, and they should be able to run the model. So I'm storing that with the model. I'm getting a sort of summary page here where I can see what I've done. User IDs, okay, all good. And then I can finish. And again, now you see that my demo model is just added to the list. So now I've decided I created a data source, I created a model, uploaded a model, and the next thing then is configuration. I need to specify how this is all going to work. These are configurations I've been preparing earlier, and here you see that I now have a label telling me what types of models or configurations I have here. And this is relating back to model type. We also have the creation, the date created, and in the case they are running, there is a start time for that, and there is the user ID. So now I can maybe first just show you how we are creating a new configuration. And this time I think I'm just going to do an edit of an existing one. There we have it. So here we have an existing config, and as you see in the selection here, I'm giving it a name, and then I can choose what type of configuration this should be. Depending on my choice now, I will only get listed the models which is corresponding to that. So as I go next, okay, I'm told that there is already an instance of this configuration. So if I continue, I'm going to upversion the existing one, which is okay by me. Here, I'm getting a listing of the models available. These models are only those models corresponding to the configuration type I'm running. So in my instance, this was PCA, and I only have one PCA model in my system. That's this one, which is called config4. And here I have some information about that model, and it's just some details there. I go next, and now I'm allowed to specify a data source. I can choose between any of these. I take the config4 data source. When I've chosen my data source and my model, I'm getting the opportunity to say something about what should be sent out of my system. And these options, they will obviously relate to the type of configuration I'm making. So for the PCA configuration, I can say that I want to have a look at the scores, raw data, and different outlier statistics. I've chosen all of them. Here I have a page where I can go in and put some indication on whether it should be auto scale, which is clicked, or whether I should have the opportunity to define ranges for my plots. I won't talk much about that. And the last one here is the last one in the setup is about how I'm going to create or display my plots. And you see I have some options, and I can then, when I've chosen the option I want, in this instance I want the one with 3 windows or 3 areas, I can go in and decide what is going to be in each area. And here I'm getting a listing then of what I decided I wanted to put out in the output. So if I hadn't decided all, there would be a limited list here. Okay, not much more to say about that. Here I have something which is called external output, because as I'm running my configuration, I can decide that I want to send the data out to a third-party system. And as you see here, what I can do, I can send it to an ASCII system, I can send it to TCP/IP, or I can send it to an OPC system. In this instance, I don't want to send it anywhere apart from to my screen and my database, so I keep it like that. And then we can start to think about who should be able to run this again. I'm not going to make any changes there. And finally, I'm getting this overview. Here I can see the decisions are made, and I can assess then whether I've been getting everything I need to do in that setup. So I'm just going to take console, go back to my list. So what I've been going through now is the setup procedure for a configuration. First, I created a data source, then I created or uploaded a model, and then I created a configuration. And this is basically what you need to do for making these configurations, and then it's just about running them. I started this first one, and I'm getting these tag areas because this is again relating to how the data are stored in the database, and I can do searches afterwards on these tags. And here I have the opportunity to define my own tags. There is one tag which is compulsory. This is the one which we call experiment ID. And then we have sub 2 here, which is not compulsory, which is product and project name. In your company, if you want to set up more compulsory tags, you can do that in preferences. I will go in and look on that a little bit later. But for now, let's say this is okay. And then we start the configuration. This one here is actually not that exciting. It's just showing me some data. And I'm just getting raw data more or less. So let's see if we have something which is a little bit more interesting maybe. Let's go down and do the PCA, which we had a look at. We're not changing the tags here because it's not that relevant for what I want to talk about. And now you see that I'm getting these two next to each other. And that gives me then an opportunity to look on both if I'm interested in both, or I can then say that no, I'm actually not interested in both. I can just keep it in the background. That all depends. One thing which we can notice here is okay, in my configuration, I have a couple of variables. So let's just get rid of that batch ID, which is not that interesting. These variables you see is pressure, temperature, and then you have something which is called multiple A and temperature ratio. Actually, those two last ones here, they are variables which I have configured in my setup, and they are then equations which is relating to my raw data. And I want to just show you that. So let's go back to configuration and stop it. And I can confirm that I want to stop it. Now you see that the date here, which I started, is the date when I started it. And you see as I'm stopping it, it's going away. But let's go in and have a look on those setup, which I wanted to show you. Here I'm saying that it's okay to up version. I'm just going to click through because this is not of interest just yet. Here we have it, because here you see that I've defined two column names, and we called it multiple A and temperature ratio. So if I now create something, create a new model, so a new variable, which is multiple B, I can go in here and create a formula. So let's do temperature B. And here we can, well, we have some functions, some standard functions we can use, but I'm going to be not that advanced. So I'm just going to have that as a multiple of maybe 3. I apply that, and now you see that I'm getting a added list, and that is multiple of 3. The multiple of A is again multiple of 3. So yeah, okay, maybe I'm a bit boring, but that is now registered with my data. Also, one thing I wanted to show you here is this external output, and here I've set up an ASCII output where I'm writing to this area, and I'm writing file formats with this naming convention. And I have the opportunity to say something about how that ASCII file is going to be set up, separators and so forth. And I also have something here which is called file size. I can decide then how large these files should be before I create a new file. And that could be, I don't know, like 500 kilobyte or whatever it is. But in my instance, I'm setting it to 0 because I want a new file for every new data item. So I'm keeping that. Permissions not going to change. Then I'm just going to say finish. I'm finished. Okay, I was successful in that. And now we can see here that this is updated. So you see that the time is updated. And if I start it now, I'm not going to change the tags here. It would probably be wise to change the tags if I should simplify my search life, but that's not what I want to talk about right now. In here, you can go in and we can have a look, and now you see that I have my multiple B, so let's put in the B as well, and let's remove it here. And then you see that, okay, this is, well, it's on top of each other, but here you see that I have a double axis. So let's remove that double axis, and then you see that, okay, you can probably accept that the red one is multiple of B, 3 times B, and then it's plotting. And as I'm generating these data now, if I go to my output, okay, here it's a bit messy, but let's do all of them, delete. I want to put them into the bin, because now you will see that as each data is coming new, there is a new item coming, or a new file coming, and it has the name which I talked about, or which I defined. And in addition to the name, you see that there is a number code here which is making it unique. So it's a pattern with the name and the number code which is created. So for each new data or sample which is going through the system, this is then written. And as I said, this could be sent to OPC as well, or any third-party system really. And that means then that if you wanted to connect directly to a control system or something like that, you could do that, and then you could send out maybe the predicted Y or something like that. In my instance, I'm sending the raw data only, but okay, that was just for demonstration. Okay, so let's move on then, because for the configuration, we can also have a look on maybe prediction. So let's do a prediction here. This is a PLS model which we have. It's actually octane numbers like that. Let's hide the other ones. And here you see now that my card it turned amber, and also I got an alarm down here. And it tells me that, okay, for this configuration, there are some samples which are outside the Q residuals limit. And if I then look on, okay, I want to go away. If I look on my plot here, my influence plot, you see that I have these samples which is outside the Q residuals limit. And they are not, if looking on the scores, they are not really outside the ellipse there, but they are outside the on the Q residuals. And if I go and have a look on if I zoom in here on the predictions, like that, for example, you see that I have my uncertainty limits, which are certainly big for these points which are outside my limits. And if I had a situation now that I was monitoring my my process using this model, then I would get some deviation here, and this would tell me that something is amiss here, something needs to be checked, and somebody really needs to do something. And also then to ensure that your operators are alert, we have put in this notifications list, because here the same information which is coming down in the alarms tab is noted, and then the operators are supposed to approve or notify, confirm that they've actually seen what's going on here, and then you see that the counter is going down and everything is good again. The alarms, they are not going away from my tile here, and they're also going into my database. So if I now if I go here to configuration, and I can stop this, for example, like that. I go to my data historian, like that, and then this one which we were looking at, that was config 8, I think, yeah. Yeah, and then it's revision number 1, and I'm going to just take data from all the time. You could, if you really wanted to be specifying this, you could specify the time as well here, but this is it's not something I'm going to do right now. I'm going to increase the number of records, doing my search, and I'm getting my results. And now you see how that I'm getting results table where I have predicted values, I have deviations, and I have some scores, residuals, and the timing, of course. I can also go and have a look on the charts themselves, and I can explore what was happening. And you see this Q residuals is sort of recurring. This is, of course, because I'm running my data in a loop, so it's the same data which is coming through again and again. And that's sort of the explanation for that. But okay, then I can look on my data, and I can go in and look on these different data points. But also, as we talked about, we can have a look on these warnings and alarms. And it's on that warnings and alarms list. We are listing all of the warnings and alarms which has happened to during the running, and for me that's quite a lot. But when you look here, you see that it's 6 samples between this and that. It's 3 samples, then it's 6 samples, and you see that it's, as I'm scrolling down here, it's 6 and 3 all the time. And again, that's relating to me running these data in a loop, of course. But that's the information there. If I now wanted, because what I've done now is that I've gone into the data historian and I've picked up some data which is relating to my process. So if I now go to my unscrambler, I can export or I can push the data to unscrambler. And then in unscrambler, I can have a look on the data themselves, and I can see whether it's something I need to change in the data. Maybe I need to change the model or something like that. And my data, they are, as you see here, they are time-stamped. And also we have these tags which I was putting in. I was putting in just demo for the tag, so it's a little bit, not that much information, but I could use it. This node here, this is the results node, and then I can also go in and look on the data node itself. And this is the spectra. This what I was looking at there is spectral data. And same as for the results node, at the end I have my tag names. So if I later then want to do some grouping, sample grouping or something like that, I can do that. Okay. Let's close that. Go back here. Audit trail. I haven't spoken about that because if I have a look in my audit trail, going to the last part here, you see that what I did previously when I looked on the notifications and acknowledged the notifications, I went in and saw that these samples, they were acknowledged, and also you see that I have the user ID for who was acknowledging them, and I have the timestamp over here. And if I now wanted to, maybe I can do a search. Maybe I can do config 22. Then I'm getting up all of the activity which has been on config 22. And as you see, this hasn't been that exciting. I've been starting and stopping this config a little bit, but not much. What I was just working on was the config 8, and here you see that it's more. And if I wanted now, I can also do some searches on from date to date. If I was in an audit and I needed to document my last month's activity or something like that, could do that. And then we could push it into a PDF format, PDF file. Yes. So let's see. Going back then to the configurations, because what we have now here is that we have a number of different configurations, and you will see we had a look now on I think it was raw material, sorry, raw, no model data there, just that. But let's have a look on another no model data here, because we have some spectral data coming through when it's arriving. And here you see that what I'm monitoring, it's, well, for those of you who know that, it's just some Raman data coming. Not, and what I can then do is that I have this option to do a transformed view. Because if I'm thinking about this, maybe I can change this. If I'm thinking about this, we had the pilot scale setup, or this pilot scale example, then maybe you have a new sensor, and maybe you want to have just a quick look on what's going on with the data as you are collecting the data. Then you can do this visualization, and you can select like I'm doing now. You see the red dot, if you call it that, the red point on the spectral data, and then I've selected that wavelength there, and I'm monitoring that wavelength and what's going on in that wavelength. So I could do that. This transformation, or what the transformation I did, it was just a simple Savitsky-Goulet derivative transformation. But I can change that. It could be in different types of pretreatments. Sorry, and if I, sorry, I turn it off there. But if I go back to my configuration and I just stop this, I confirm the stop, and then I can go and do a review of that configuration. Yes, I'm accepting that it might be a change to it. Here is where I have my derivative, and here you see that I've done a first derivative and I've done some smoothing points. But actually I could do some other pretreatments as well. This list of pretreatments is, you might think, quite limited, but we've done this on a purpose, because what we want to give you, we want to give you the opportunity to have a first look on data, and these ones, they are typically of interest. But if you want to do a pretreatment for your models, then of course you will do that in the Scrambler itself as part of the model building. And sorry, and that's going to be much more wide. The options are much more wide, and you can really do all of the advanced pretreatments you want. But of course, if you have a data source which require that you have a special transform in here, then you should talk to us, and you can then see what we can do. You can also do, it's not going to be that meaningful as such, but you could do things like baseline in addition to the derivative, just to show you that. and then you can change the sequence and all of that. So yeah, not going to talk more about that. Let's think here then. We have showed you no model, so we can take that one away. We have showed you PCA, so we can take that one away. Maybe now we can show you a little bit of, should we call it a case study? Because we have, if I go to the Unscrambler just to show you a story, I'm not going to click through all of the details here, but I'm just going to sort of put it into a context, because what we have here is that we have a chemical process which is running with a number of different variables, and it's not that important what these variables are for the purpose of my discussion here, but it's just showing you that this is sort of the data set. And through the data set, we also have some settings. You see that it's sort of an more or less an experimental design with some state stuff, different states. So we can look at that. We have state 1, state 2, and state 3 with the state variable. And then we have a calibration set, which is here, and we have a prediction set, which is here. So this is all set up then in a Scrambler as part of the data analysis. When I've done my analysis, or when I do my analysis, maybe the first thing I do is to do a PCA. In the PCA, I see that, okay, there are some groupings here. I've done some coloring now on the quality variable. And maybe I should mention a quality variable for you, because that's this one here. We call it luster. It's relating to the surface properties of the product which is made. But if I'm coloring then or grouping according to the luster levels, it doesn't look like it's much related to that. So let's you see, this is my grouping variable. So let's increase the number of groups. I can apply and it's okay. Well, maybe as I'm increasing the number of groups, I'm getting something here which is relating to different levels of this variable. So maybe there is something there still. My variables, they are over here, of course. This is the loadings, scores and loadings, and this is what it looks like. So, okay, I'm thinking that there might be an opportunity here to create a calibration model between my process variables, my process parameters, and the quality variable, which is luster. So I go away and I do that. And then again, this is my scores, and I can put in the sample names, take them away to clean it up. And we have the variables over here. So then we have luster showing as well. And we see that, okay, down here, I'm getting sort of a relation where I have predicted and reference values. It's all sort of looking okay. Exception is probably this one here, which is we see as an outlier. And as you see, I've marked this here. I can sort of unmark it and mark it again. Let's see, we do like that, and then we can mark it again. And then you see that it's also showing up here in the scores plot in the center of the scores plot, and that means that it's not really visible, at least in the first two factors, and maybe not even in the higher factors either. But in the relation predicted versus reference, it seems to be standing out a little bit. So this one, we remove that. And okay, I'm getting something here which is even better. And I'm getting a fairly good relation of what's going on. So what I now do is that I've been using a tool in Unscrambler which is called significant variables. So I found the significant variables in this data set here, and you see them marked. If I then just do a PLS on those significant variables, things are starting to look even better. And I can put in the lines again, and then we see that we are getting a good model. In the plot now, you see the variables which are used in the model building. They are blue, and those which are excluded, they are green. So we can actually see that what they would be like if they were part of the model. But this is the model now which I'm going to use. And I've saved this and I've uploaded it. And it is this one here, which is called config24. So when I then move to the running of this model, this configuration, we can look at it like, well, shortly. And here you see, well, first we see that, okay, there are some samples outside. And this is an important observation because what I'm going to show you here is quite a good deal of samples which are outside. But let's have a look then if we can zoom in here on the predicted value, and you see that it's running, and everything is good apart from that we have a lot of these samples which are outside. And it's the same situation which we had for the octane data, that actually in my scores plot things are looking okay, but then there is something here which is really going on. So in terms of the data I'm running through the model now, these should give you concern, because this is something which is amiss, or something is wrong. So this is giving reason to believe that either I need to go back and do something with my model because the context of my new data has changed maybe, or there is something else which is really going on. What I can do then is that I can of course compare it to the running, not the running, but to the previous data. I can also drill down to what was the data, what is the data, and you see that I'm getting my all of my variables. I'm getting the values for the variables, and I also can look on these min and max variables, and we see that. Well, let's make that bigger. We see that here we have a variable which is really at the edge of where we've seen it before, and there's one here as well. And we can start to think about what does this mean in my process. Um, I won't really go into the details of that in sort of this presentation, because in this presentation what I've tried to do is that I've tried to give you an overview of how the process pulse can fit into a sort of a process monitoring regime. But if you are interested in more details or more talking more about the methods and everything like that, just get in touch and we will work something out. Then I think even if we're early, I was planning to give a lot of time for questions. So the last thing I'm going to do now before looking at questions is to just show you these preferences. Well, taking note now, of course, that even if I'm moving around in different regions of my program, of my process pulse, the cards, they are always visible. So if I suddenly got a situation here now with something going wrong or something going outside my statistical limits, then my card would be flagged up like you see it now. And my attention would be drawn to that, and I would go and have a look at it. Yeah. In the data source setup, it's not that exciting. You see that I can do something about the layout. But in the model one, this is where I told you about these settings I didn't want to talk about. But this is where I told you about these tags, because I had 2 tags for my models, but here you can go in and fill in the tags you are interested in. And if you want then to make some of them compulsory, you just tick the box and that's done. The tags you put in, they can be text fields like I had, or they could be roll-on lists. Roll-on lists could be things like if you have 3 products which you are running models for example, you could have those 3 products on a roll-on list. It's the same for configuration, because here, if I do the next, oops, didn't want to do that. Let's do like that. If I do next, you see that I have the same opportunity to extend my list, and also you see that I made this experimental ID compulsory. The product and project name I can change if I have other tags I want to attach. I have some system settings and alarms and warnings. We talked a little bit about that you could send by emails. And if you want to send by emails, you need to specify who should be receiving this. And also, we have some technical specification about the setup of the email system itself. So I won't talk more about that. Okay, that should be okay. So what I then want to do is that I want to have a look on any questions and see if I can manage to navigate that. Let's see. Questions? None. Well, that's good, I guess. Are there any questions? Okay. I take that maybe as a no as well. Let me see how if I can see any raised hands here. No, can't see any raised hands. So what I assume then is that this was pretty clear for you all. And if it wasn't, I guess you have to tell me. I gave you the email addresses, and I will put that one back up again. So here we go. Yeah, okay. So I'm told that maybe I should take a chance here and unmute you. I'm not sure if I dare, but okay. I will do that. I will unmute you and see if there is anybody who's saying anything. So let's see. No, I can't do that. No, I can't do that. Okay, we just resort to email then. None of you put in any questions in this system, as far as I can see. No, I was too quick. Let me see here. There are some questions. Can you talk about soft bugs? Okay, there are a couple of questions here. Let's see. There's one question. Soft sensors, a bit more about that. And an empty one. Output interface. Software for PAT. Yes. Yeah. Okay. So this we can answer some of these questions. First one, there is a question here about whether I will be sharing the talk, and then I assume that it's the slides, or is it the recording? Slides. Yeah, we will be making the slides available. So I guess will we be sending it out, or will we be making it available on the web page, or available on the web page? Yes. So we will be making the slides available on the web page. So check the web page, camo.com, and we will have a pointer to the slides there. Okay, then I can take that one away. And then there is a question here about what's the software for PAT. Then I have to say Unscrambler and Process Pulse, of course. That's our software of choice. But there might be more to that question that I'm understanding. So please get in touch if that wasn't the answer you were looking for. That's the one. Okay. And then we have a question here about showing the output interface in a bit more detail. Yeah, I can try to do that. output interface, because then I assume that it's relating to the output interface for external output. So let's just go in and have a look on that. That was in this configuration here, configuration 18. Let's see, here we have external output. Because now what I have here is that this is what I showed you, that I have an ASCII specification and I have the raw data which can be sent out there. I can also, if I do the OPC, I haven't set that up in my system, but in that case I would be able to browse my system, and here it's, well, we can do the different formats of OPC, and then it's just to do the local servers. As I said, I haven't set that up, but then if I were to do that, I will select one of them, and it would be like a normal OPC setup. And we can also do this TCP/IP, where we have a host and a port which we are sending data to. And then for this no model configuration here, it's only the raw data. But in the case which I had a model, I would also have predicted data which I could send out, like Y predicted or score values or something like that. And okay, if you need more information than that, I can talk about that. So let's see, go back here and see if we can find more questions. So that one I hope I answered, and if not, please get back to me. Does Process Pulse work only under Windows OS? Yes, the way we've done that is that we have compiled it for Windows. Obviously, there is a source code here, so if it's specific requirements, please tell us. But yes, it's only for Windows. Let's see, that was on. Can you show something using moving block in Process Pulse? Yes, I can actually do that. Because if I go in, let's see if we can hide this one here. Because I have a moving block set up, which is config 14. So let me just start that one. And the same startup as before. Let's see. And you say that you use moving block for blending, and I think that's a really good idea. It's probably what I would be doing as well. So that should be working. This moving block now, it takes some time because my simulator is set up to give a measurement point every 5 seconds, and then I can't really recall how many points I had in my block, but obviously I need all of those points coming before I can use this. And what you see now, it's fairly straightforward actually, because you see the spectra which is coming in, or which are coming in, and also we have just moving block standard deviations plotting in the upper right, and we have the moving block mean plotting in the lower plot. The idea now is that as we are running this moving block, we should be looking for limits. So if you are doing blending, I would think that you're getting some sort of profile going from large variation to small variation, and you will be trending that, and you're putting in a limit, and then you would be monitoring when you are crossing the limit and setting it up either to send the result to a control system externally, or setting it up like this, so you're getting a warning when things are coming to the end point of the blending, and you can stop your blender. So that should be. I only have this sort of simple setup here, but in terms of using this for endpoint detection in blending, I think that will be fairly straightforward. And of course, if you want to discuss it in more detail, just please let me know, and then I assume that that's okay. And then thank you for the webinar. Yeah, that's no concerns. Have to leave. Okay, no worries. Is it possible to sign configurations and/or model electronically to release or protect them? Yes, we have this. approve mechanism. I don't have any really good examples of that here in my setup, but if we look on the stuff here, because what will be possible to do is that you see on my list here, I have start and stop states in my configurations. I also have this approve state. In the current implementation or in my implementation, clicking the approve just approves my config. The idea here is that you should also be asked for your logon details. And that means that if I'm eligible for approving this model, then I'm allowed to approve it. If I'm not eligible, I'm not allowed to approve it. And the opposite way, if I want to, protect it, I can click here and then I choose this disable. And as I'm choosing disable, you see that this state is again changing to approve. And this means that my configuration is now in a disabled state. And this is for configurations. If I go to models, you will see that I have the same thing. I can click my model and I can disable it. And then you see my status is coming up as disabled. And if I want, I can show them or I can hide them. So that's here. So yes, there is some functionality for it, and of course, whether your requirements is fulfilled, please get in touch and we can discuss the details. Okay. Yes, can process pose 2 be used to analyze large amounts of historical data from a database? The answer to that is that initially, well, there are two ways of looking at this, because the initial suggestion here would be to take data from the database into Unscrambler, because in Unscrambler we can do the analysis and then we can do exploring the data, and we can find relations in your data and hopefully then create a model. And the idea then, if that database is describing something you are still doing, then you can take the model which is developed using the historical data, and you can move that to process pulse, and you can use the model there to monitor a normal operating region or something like that. And in that case, you can take the opportunity to actually use the knowledge or the historical knowledge in your data for the new data, for the new manufacturing. You could think about actually transferring the data from your old database into a process post database and accessing it through process post. But in a sort of normal situation, that would be a lot of work with very little benefit. So I would say that it's better to then just analyze the data using Unscrambler, upload the models to process post, and use process post for the new data. I think that would be a better approach. Yes, there is a question here about, can you log off from process post 2 and another user with the same user level can log in and continue working with process post 2? The answer to that is yes, and you can even have several users on the same user level working at the same time, because this is it's a server client setup, and if you and your colleague both are users, you can have each of your laptops or desktops, and you can have process post installed there, and then you can log in with your credentials and your colleague can log in with her credentials. And even if you have the same user access level, you can work at the same time in the system. Obviously, you can't work on the same configuration, but if your colleague is running a configuration like I'm running configurations now, and you have access to those same configurations, then you will be able to see that those configurations are running. So that means then that if your colleague is starting the configuration and you are logging in half an hour later and it's still running, you will be seeing what has happened during the run of that configuration. Okay. We have had issues with unscrambler model sizes in the past for certain customers. is there limitations within poles? No, that's not limitations within poles. And also, um, I don't know what issues you're talking about there, but in theory, at least, there shouldn't be any issues with model sizes apart from the hardware restrictions. I know there were some limitations when we were talking about 32-bit because there is a limited number. I think it's 2 gigabyte of addresses or something like that. And if it's that you're referring to, yes, then that's an issue. But that shouldn't be an issue here with process poles because that's should be able to run any type of models as long as the hardware is supporting it. So if you have some extreme requirements, should we call it that, then just let us know and we can do some specific testing here for you and ensure then that your system is actually not too demanding for process poles too. Okay, thank you for the explanations. Good. I assume I answered some questions then. The fact that you can use what you are predicting as a data source. Okay, so that's yes, that's right. I didn't show that, and also I haven't set it up in my system. But if I wanted, because my in process poles, I can send external output, as you saw, to ASCII, to TCP/IP, and to OBC. We also have an output source or output destination which is called process poles, and that means that as you are running a configuration and maybe you are doing predictions, you can send the prediction results back into the data source or in as a data source in process poles, and then you can, for example, trend the prediction in a moving block model or something like that. And that means then that you can chain your models to some extent, and you can create more advanced setups for monitoring of the system. And if anybody are really interested in that, just let me know, and I can drop you an example, maybe a couple of slides or something like that, showing how it will be working. I can even set up a demo for you. But then I need to prepare it. And this demo here, it was prepared for the sort of generic functionality. But as I said, if you're interested, get in touch and we sort it out. Okay, that's just a hello. That was the one I just answered, and that's great. Yeah. Soft tags using the same data as you. Yeah, this is the same. This is actually the start of the same question. This situation that you can actually take outputs from the model and you can feed it back into the data source. So yes, that's possible, and as I said, I can provide more information on that. And also, I assume this one here, it was a generic introduction, and we will be planning to do some more specific webinars on chosen topics later. But this was just to present to all of you what process poles is and what the sort of generic capability is, what you can do with it. And hopefully you will be interested in the follow-up presentations as well, where we will start to talk about certain applications and more specific methods. Okay, if no, I don't have any more questions on my list, so I just take back that information slide. As I said, my email address, grf@camo.com. Any questions relating to getting hold of the system, send Jostein an email on sales@camo.com. And also reminding you then that we will be running training courses in PAT, where we will be talking in detail about what you can do. We will be running training courses in DOE in November, and in addition to these MVA1 courses we are running more or less continuously. And also there are some webinars coming up, and particularly the batch webinar, I think I will encourage you to look at, because we have an exciting new method there for batch, which we will be presenting in September and October. So keep your eyes open on the camo.com website, and yeah, hopefully that will be good. Okay, There's a thank you for presentation here, so that's closing there. Unless you have any more questions, I'm planning to close early for you so you can get back to what you're supposed to do. So can't see any more questions. Thank you very much for attending, and hope to hear from you again soon. Yeah. Thank you. Bye.